Hello everyone, welcome to OneClass Services channel. My name is Devansh and today in this session we'll be going through some. So basically, this session is going to be a Q&A session of mathematics, and so a little bit background about myself. So I'm in the final year of my graduation in aerospace engineering, and if you need any tutoring help or if you need any one-to-one live sessions, then you can check the links in the description below. And so without wasting your time, let's just begin with our lesson today. Mm, uh, don't look at the solution that was from previous one. Yeah, just a minute. Yeah. So we have the first question here. Mm, just a minute. So this is question number one. So um, we need to prove that the square root of 17 is irrational. Subsequently, prove that n times the square root of 17 is irrational too for any natural number n. So I'll just first write the problem statement here. Proves that square root of 17 is irrational. I'll just rewrite this. My writing looks very horrible right now. So uh, I'll just leave this. This also doesn't look good. Yeah. So subsequently prove that n times the square root of 17 is irrational too. So for this proof, I will go with the solution given here because this is a lengthy kind of proof and I'm not good at memorizing things. So first we need to prove that again, yeah. So let's say that square root of 17 is p over q, where p and q are integers, uh, prime integers to each other. That is grade of p comma q is equal to 1. Then squaring on both these sides will get 17 equal to p square over q square. Now I can just multiply q square on both the sides. So I'll just multiply q square on both the sides. So I'll get 17 q square equal to p square. This is going to be our equation number one. Then we have what we'll do in this equation only, where I multiplied q square on both the terms, we'll be dividing it with p square, and then I guess we need p down here. So we need this in terms of, yeah, so that will be 17 over p square, sir. So we'll be dividing both the sides with 17 and again, yeah, multiplying both the sides with q. So this will become p square equal to p square over 17 equal to q square. Now that means um, p equal to 17r, and let's say this is our second equation. Now for some any random integer r, if I do the squaring on both the sides, then the square of 17 square is 289. So what we did here, basically we just wanted to find that um, like this is a mathematical operation, or it is a kind of procedure, so that we can say p is nothing but 17r, because 17 q square equal to p square and p square over 17 is q square. So like P is equal to 17r, then P square equal to 289 r square. This will be 3, and therefore what we'll do, we'll substitute this third equation in the first one. So here we had 17q square equal to p square was 289 r square. Now with this, this is 17q square equal to 289 r square. This means q square equal to 17 r square, and this looks familiar, I think. Yeah, so this first one and the last one look similar. Now let's check the definition here also. So q square over 17, therefore q over 17, which implies that q equal to 17r. Now where r is some integers from 2 and 7, again we'll do q square over 17, therefore q over 17 equal to r, or q equal to 17r. Again we'll substitute this q equal to 17r, or q square equal to 170, sorry, this will be 289, I guess. 289 r square, this is 4, and this will substitute, I guess. Okay, so I did one squaring extra. This is supposed to be the fourth equation, and we'll substitute this 4 in 2. So 4 in 2. This will give me P equal to Q. Now, which contradicts, so from here we have P comma Q of 17, which contradicts our assumption that get P comma Q equal to 1. So root 17 is not rational, that is root 17 is irrational. Now we have to prove that n root 17, means we have to prove for n root 17 is irrational where n is a natural number. So again we'll write n root 17 equal to p over q, again for p over q, p and for p and q for of some integers where q is not equal to 0, or this will become p over qn. And again it is contradicting with the statement above, because it should be p comma q should be 1, and here the left side is irrational number whereas the right side is rational number. So oh, I forgot to write this. So here again the right side is irrational and left side is rational. So again this is not true, and n times square root of 17 is irrational. Like such kind of proofs are not ours. Like I have never encountered such kind of problems in my life. But yeah, I know that square root of 17 is irrational. So I'll just write correct solution. Good work. Okay, so we need to go for triangle congruent theorem. Question number 2. So I'll just take the reference from the solution given here, because Like I know the ASA, SSS, and SAS, but yeah, like here they have given it in a proper definition, so I'll just read this. So basically there are 5 theorems. So let's say we have a triangle, and let's say this is, and I'll draw one more. Now what we'll be doing, let's say this angle is 90 degree. Yeah. So I have five theorems. So let's say this angle is angle at D, and this angle is angle at F, and this is the angle at A, and this is the angle at C. So first one is side, or SSS, side, side theorem. So it states that if all the 3 sides of the two triangles are equal, not like not for a single triangle, but for the both of the triangles. So basically, if AB is equal to, let's say, DE, and BC is equal to EF, and AC is equal to DF, then both the triangles are congruent. Triangles are congruent. I'll just read the definition. 3 sides of one triangle are congruent to the 3 sides of another triangle. So basically 3 sides of the first triangle is equal to the 3 sides of the other triangle, and then the triangles are said to be congruent. We'll go for the second one. So second one is side angle side, angle side, or SAS. So basically it states that one side should be equal to another side, then one angle, and then one side. So basically here I can say that AB is equal to DE, and then we have one angle. So let's say B is equal to E. So angle B is equal to angle E, and then we'll go for another side. So that will be BC equal to EF. So for this theorem, keep in mind one thing, that the angle should lie between the two sides. So you like we should take the side should be what we say that the side should be like just next to another, and the angle should be between those sides. Like I forgot the exact term. I'll just, if I remember, I'll just tell that the exact term for this. mm, so I'll just, yeah, so the exact term was corresponding. So the two sides and the angle between the congruent between are congruent to the corresponding parts of another triangle. Now we go for the third one, which is angle side angle, or it is ASA. So for ASA, we need one angle, then the side next to that angle, and then another angle. So basically here, let's take angle at A. So angle at A should be equal to angle at D. Then we need one side, so we'll be taking DFAC, because again this is the angle, then AC is the side, and again angle at C and angle at F. So this will be angle at C and angle at F. So they should be equal, and yeah, so it forms, I'll just read the definition here. So the two angles and the side in between are congruent to the corresponding parts of the another triangle. We'll go for the fourth one. Fourth one is angle side, or AAS. Now for this case, two angle and the non-included side. So basically any two angles and one side is equal, then a triangle is said to be congruent. So uh, it can be these two angles, and let's say this side or this side or this side, so any side. Like if it is these two angles and this side is included, which is between them, then it will become angle side angle. But it, like, for this we'll take the angle at A, angle at B, and BC length. So it will be like this: angle at A will be equal to angle at D, angle at B will be equal to angle at E, and from this AB BC equal to EF. Or we can say AC equal to DF. So we can take like BC, or we can take an AC, like any length we can take. If we take the length which is between those two angles, then it will become angle side angle. So it is like, if it is specified that we need to use angle side, then we cannot take the angle which we cannot take the side which is between those two angles. We need to take the other two, we need to take one of the other two sides. And for the fifth one, so fifth one is nothing but it is just an application of one of the theorems. So it is RHS, which is right angle, hypotenuse, and side. Uh, Angle, hypotenuse, sides. So it states that the hypotenuse and leg of one right angle triangle are congruent to the corresponding parts of another right angle triangle. So it states that if this hypotenuse is equal to the hypotenuse of another triangle, both of them are right angle triangles, and one of the length is equal to the another of the length. So let's take AC is our hypotenuse, obviously, so AC equal to DF. It can also be an application of angle side angle or side angle side, like it can be an application of, I think, yeah, side angle side. So basically if the angle is 90 degree and one side is included, then definitely, like, it is an application of other theorems. So let's say AC equal to, for AC, what side we had, DF. AC is equal to DF. Then we have angle at, I think, I guess it is at B. Angle at B equal to angle at E, which is 90 degree. And this is only valid for right angle triangles, not for any kind of triangle. So let's say if EF is equal to AB, let's say that. So EF equal to AB, or if EF was equal to AB, then BC will be equal to DE, or then we can use this kind of theorem. So again, I'm saying that this fifth theorem is just the application of the theorems mentioned above, and it is only valid for right angle triangles. So I guess that is all for this one also. So I'll just write correct solution. Solution given here, and I'll just say the solution is correct. Okay, so we have a lengthy question right now. This will be question number 3. Yeah, so I just write question number 3, another proving question, I guess. So prove the reverse triangle inequality, that is for any vectors x and y in uh, domain of real number r power n, magnitude of x minus mod of y whole magnitude is less than equal to x plus y magnitude. Let me just check that this magnitude is okay, I guess. Okay, so to prove the reverse triangle inequality, we have to show that okay, I know that. Then we use the triangle inequality, which has the form. I'll just first write the question itself. So that will be, we need to prove reverse triangle inequality, and reverse triangle inequality, that is for any vectors x and y in our real number range, and we need to prove that this statement is valid. Let's take the hint. So hint, consider the cases mod of x is less than equal to mod of y and mod of x is greater than equal to mod of y separately. So then we'll start with the solution here. So first, yeah, okay, so in the next statement they are taking one example, which is the, sorry, I have drawn more than one, I guess. So it is the triangle inequality. So we can consider then is equal to x plus y minus y, then magnitude of x is less than equal to x minus y plus y. Then we'll be having, we can take this on this side, so it will become minus magnitude of y is less than equal to x minus y. Now we'll do the same for y. So again, I don't like this two signs. Then y will be less than equal to y minus x plus x. Then again we'll take x on this side. One minute. However, since x minus y equal to y minus x, we can express the above expression as, okay, so the thing is that magnitude of x minus y is going to be equal to magnitude of x minus y. So we can first we'll do what we'll do. We'll write magnitude of y is less than equal to, we can replace this term with the term given here. So it will be x minus y, and then we had an x here. So again we'll take this x on the other side. So this will be minus x, and then this will be x minus y. Then we divide, I guess they are dividing here, I guess, yeah. So they are dividing both the sides with minus of 1. I think that dividing both the sides with minus of 1 will change the inequality sign. Both the sides with minus of 1. So this will become x, then minus y. This sign should change here. Combining the two inequalities, magnitude of x minus magnitude of y is less than equal to x minus y, and minus of x minus y is less than I guess they have done one mistake. So if we divide both the sides, or if we just multiply both the sides with negative of 1, then the sign of this inequality will change. So basically this will become x minus of y, and it will become greater than equal to x minus y. So one condition we have this, and the other condition, yeah, so I have to write one minus sign also, and the other condition was x minus y is less than equal to x minus y. So I'll just write x minus y is less than equal to x minus y. Now we can write this. So this term will be less than this, and this will be greater than this. So we can just combine these two statements. So this will become minus of x minus y is less than equal to x minus y. Then it is, and this one we can just write um, I guess um the middle. Okay, yeah. So middle term was this one. I got confused. Okay, yeah. That's why I was thinking that I have done any mistake. So this one is the middle term, and yeah, we'll just copy this. Therefore, so this statement clearly states, and therefore we have proof that magnitude of x minus y is greater than equal to x minus y. So here I guess here they have done a mistake. That is, I'll just write this mistake, but yeah, the final answer is correct. They have proved it correctly. Just they have committed a mistake here, and I'll just tell them. And rest all was, I guess, or rest everything was correct. Correct solution. Only mistake made here was when dividing with -1, sign of equality changes. So it will become greater than equal to. So it should be, I think I can write this x was x minus y minus of x minus y should be greater than equal to um, x minus y, but rest of the solution was perfect. Yeah, so I'll just write the solution was correct. So again we have a congruent term. Okay, so question number 3, this will be question number 4. So it is saying that what does congruent mean? Okay, so first congruent. So first I'll read the definition. So in geometry we say that two objects are congruent if they are exactly the same, meaning to say if we overlap or superimpose them, then they fit perfectly. So let's say I'll take a parallelogram. I was I was I wanted to make a square. I'll just make a square here. And one more. I I'm not sure that I would be able to make the exact same square. So I'll just play a trick here. So what I will do, I will just cut this and I'll copy this and I'll paste this. And so let's say I have two squares. Okay, obviously I have cheated here, but the main idea was to explain you. Let's say this is S1 and S2. So in geometry, what we do, whenever we want to say that the two figures are exactly similar or not similar, exactly equal or exactly same, then we use the term congruent in geometry. So what it means that when if suppose mm, again I have to this cut this. So if suppose I take this square and I keep it on the other square, then I won't be able to find any difference among both of them. So both of them like they just stick to each other. Like it is not a case where this is one square and if I'm just pasting the another square over it, so it is looking like this or something like this. So it should like exactly cover the other one, and we cannot see the other figure um, behind the figure which we have just pasted. um, so in those cases we say that the figures are congruent. I cannot put this square here, so I'll tell you with another figure, one more figure. And so let's say I have let's say a figure. um no, this won't do any good. I just rub this. I don't want this. um let's just say I am making a circle here, and I'll make another circle here. Okay, and I'll return back just a minute. Where was that tool? Shape recognizer. Okay, and let's say I'll just copy this, copy and paste. Okay, so let's say this is one circle, this is another. I'll just say this one is, let's say, C1, this is C2, and this is C3. Now what I'll do, I'll try to cut this figure and paste it on the other figure. So if I'm able to see the other figure, well, basically this circle is bigger, so I'll just cut this C1 and try to put this in the above C2, and I'll put these figures so that these centers or these circles are concentric to each other, and I will see if I am able to see the another circle, then the figures are not congruent. So if I paste it here, you can clearly see that I can see the circle C2. That means that the circle C1 and C2 are not congruent, and I have almost aligned this perfectly so that they are concentric to each other. Now I will go for the just a little bit from here. Just yep. So you can clearly see if I release this figure here, you can clearly see that the two figures are superimposed with each other, and um, we cannot see C3 circle here. So it looks like we have made a circle. Sorry, it looks like we have made a circle and we have just written, where is shape recognizer? Yeah. So it looks like we have made a circle and we have written C1 here and we have written C3 here, and the circle is a little bit bolder compared to other ones. But the thing is that this proves that C1 and C2 are congruent, but C1 and C1 and C3, this should be C1 and C2 are not, and hence if C1 and C2 are not congruent, then C3 and C2 will also be not congruent. Similarly, we have congruence theorems in the in for triangles, and then we are just talking about congruence, but we have concept of similar triangles also. So yeah, that is, I think, pretty much all. Like, in short, we just take both of the figures, we paste it on each other and see whether we are able to see the other figure behind the first one, or the second one, doesn't matter. But if we are able to see the other figure, then they are not congruent. Obviously, we might have to align the figures a little bit so that they match, or they, like, we need to align uh, both of them in such a way that, um, like, the first figure can cover all the sides of the another figure. So our aim is to make the figures congruent, but after rotating the figure for 360 degrees also, if we are not able to find any location where we can just say that the I cannot see the other figure behind this one, then we can clearly say that the figures are not congruent. But if it happens that after some kind of rotation or some kind of adjustment, if the first figure overlaps the other figure completely, then we can say that the figures are congruent. So I'll just say correct solution. Good work. I guess this was question 4. This will be question 5. Mhm. Um, it is given that cotangent theta of negative 3 over 8 and theta terminates in quadrant 2. Find the exact value of all 6 strict functions for theta. Express your answers as reduced fractions. Decimal answers will not be accepted. So what we'll do here, and the theta terminates in quadrant 2. So in the quadrant 1, all angles are positive. In quadrant 2, sine and cosecant are positive. In the, I think, for the second one, yeah. So, and it is saying that the theta is in quadrant 2. So sine and cosine will be positive, sine and cosecant will be positive, and all the other angles or all the other ratios will be negative. And cotangent of theta is given as negative 3 over 8, and cotangent of theta is base over opposite side, or I can say adjacent over opposite side, over opposite side. So it means that we have a triangle in such a way. What is happening here? We have a triangle. Let's say this is another line, and this is a right angle triangle in such a way. Now, one thing I want to mention, that with trigonometric ratios, we do not get the exact value of sides. They are just ratios. But let's say the side, or the, let's say the ratio is 1 to 1, so I can just write these sides as adjacent. If say this one was theta, then this will be 8 and this will be 3. I'm not writing this minus sign because according to the ratio I'll just put a minus sign, because this is length and length is in positive, so I'll just use magnitudes here. So this is 3 and this is 8. to find the hypotenuse, we'll just use the Pythagoras theorem. So it will be, hypotenuse will be square root of 8 square plus 3 square. It will be square root of, this will be 64 plus 9. This will be 73, I guess. I'll just cross check with the solution. Okay, so they have directly found the angle also, but yeah, so okay, so they have directly found the angle using calculator. What we can do, okay, I'll just go with 73, I guess. It should be 73, I guess. Yeah, it should be 73, and 73 is irrational, I know that. So I have to directly find the square root of this. From the two values theta equal to 115, the angle is, so they are using the calculator here. Okay, so what I'll do, I'll find the square root of 73 using my calculator. So the square root of 73 is 8.544. So this will be 8.544, and yeah, so cotangent theta is negative 3 over 8. Tangent theta is 1 over cotangent of theta, which will be 1 over negative 3 over 8, and that will be negative of 8 over 3. Now we need sine and cosine. So for sine theta, it will be opposite over hypotenuse. So 8 over 8.544. 8 over 8.544. This will be 8 over 8.544.93, and sine, okay, 0.936, correct, I'm getting the correct answer. 936. Cosine of theta will be, adjacent is 3 over 8.544. So this will be 3 over 8.544, 0.35112. And yeah, we have to write the answers in I guess fractions. So I'll just write this 936 over 1000. Oh god, this is going to be a really hectic job. I have to do the division yet. Okay, I'll just cross check with the division given here. I'll just cross check this value. So for, I guess, yeah, okay, yeah, so we need to put the negative sign. So for sine it will be positive, tangent it is negative, and for cosine it will be negative. So this is going to be okay, positive, and I'll just calculate that what is 117 over 125 and 0.936. So we can directly write this as 117 over 125, and for this one they haven't done anything, so I can just write 351 over 1000, obviously negative. Then again, cosecant is 1 over sine, and sine is positive, so cosecant will be positive, so it will be 125 over 117. I'll just taking the reciprocal of this, nothing much. And we have cosecant. Secant, we need to find secant, so secant will be 1 over cosine, and that will be 1 over minus 351 over 1000. That will be 1000 minus and then 351. Have they done something? No, they haven't solved this further. So I guess, and yeah, obviously you can just calculate. It will be 110 only because, so I'll just explain one thing that um, for the given case, cotangent is negative and cotangent is going to be negative in second quadrant, this one, and in this quadrant. So in these two quadrants, cotangent is going to be negative, and if we just write the value or if we find the angles, then we'll get two angles. One will lie in this one and the other will lie in the fourth quadrant. But in the question it is given that the angle terminates in quadrant 2. That means the angle is in quadrant 2, so we'll take the angle which is 110. So theta is 110.55 degrees. We'll take this because the other one will be somewhere around here. It is negative, so it will be like this, 66.44 degree, and we won't be taking because it is in quadrant 4. So I guess that is all, I guess. Yeah, that is all for this question also. So I'll just write correct solution and then good work, solution is correct. And we'll be going to our next question, will be question number 6. Oh, what happened? Mm, yeah, so this is going to be our question number 6. So what is sine of 30? So just by looking at the solution only I can tell what is the solution, just by looking the half of the figure, because I know I like this kind of solution or this procedure. The one way to find sine 30 is, so look, basically there are values for calculating sine and cosine. Basically there is a general table which has the value of 30 degrees, 0 degree, 45 and 90, and I will always suggest that you just memorize that table because that will help you a lot. But second approach is to use the unit circle, third approach is to use your calculator, and the fourth one is to just play with a triangle. So this is an equilateral triangle. Let's say A, B, C. Length of each and every side is A. Angle is 60. All the angles are 60. So I'll just write 60, 60, and this whole complete angle is 60. Now what we do, we just draw a perpendicular from the one edge to the opposite side. So in equilateral triangle, what it does is that first it breaks the other side in two halves. So this will become A over 2 and the rest will be A over 2. Second, it also bisects the angle. So this is 60 degrees, so it divides it in two equal half of, which is 30 degrees. So the angle will become 30 degree, and obviously this is a perpendicular, so this will be 90 degree. Now we need to calculate, I guess, yeah, so we need to calculate sine. So for sine, we won't be needing this length, the length of the perpendicular, but we can just calculate the length of the perpendicular. Let's say this side is AD, so we can calculate AD will be under root of AC square, which is hypotenuse square, minus the square of base, and then we'll get root 3 by 2a, I guess. Yeah, but the thing is that we won't be needing this length, because for sine we need the opposite length and the hypotenuse, which we have. So sine theta is opposite over hypotenuse. In our case, sine 30 will be opposite is DC over hypotenuse is AC. Now DC is A over 2 and AC is A. So this and this will get cancelled and I can write sine 30 as 1 over 2, which is the correct value of sine 30. We can also calculate cosine. It will be, I think it will be root 3 over 2, and we can calculate tangent, that will be 1 over root 3. So again they have given the first approach, the second approach, they have also given the second approach. So I'll just also explain that also. So basically, if you have the unit circle, so to calculate these trigonometric ratios for a particular angle, what we do for the angle, for the line which has that angle, so let's say this is the line of 30 degree, we take the coordinates of x and y. Then for unit circle, sine of theta is nothing but the y coordinate, cosine of the angle is nothing but the x coordinate, and tangent is nothing but y over x. So here I can say sine of 30 degree is going to be the y coordinate of this, so this will be 1 over 2. X1 is root 3 by 2, so cosine will be root 3 by 2. So again with the unit circle we can calculate the angle, and I guess again that is also pretty much everything for this one also. So I'll just write correct solution. Good work. It is just asking for scale factors, I guess. In mathematics, scale factors the ratio of corresponding sides of two similar figure. Look for the example shown below. So we do not have any example here. I guess I have to stop at this point um, because I cannot find any. Okay, so I'll be ending this session here itself. I'll just end this here. Um, so yeah, that was pretty much everything for this session, and if you like this session then please do hit the like button, do subscribe to our channel, and do hit the bell icon so that you will be always updated with our next live streams. And again, then you can check the links in the description below. So I hope to see you soon in my next video. Till then, bye.